Greetings, tubers. So one of the things I haven't told you is that currently I'm living off grid here. That means we've got no electricity supply or no provided supply, and no water mains. So I am the electricity board, and I'm also the water board. And recently we've had a failure of a water pump, so I bought a new one, put it in, and the pump worked, but the pressure sensor didn't. And here is the offending item. So if you see that on Amazon, don't buy it. It's this. Here's the pump here, and there's a pressure switch here, and that doesn't work. That particular item has got really bad reviews online, and everyone says that they fail or either didn't work on arrival. So I've decided not to replace it. So what I've done instead is I bought another pressure sensor, which is here. It's an electronic one, so there's very little chance of that going wrong. And it produces a voltage proportional to the water pressure inside this pump in pipe. And I've built a circuit over the last couple of days, and here it is. So this is the pump control circuit. It switches the pump on and off according to the value that it gets from the pressure sensor. So in the next couple of days I shall be putting that onto a permanent board, sticking it in a box or a container, and I shall video that progress as it happens. And then for anyone that's interested, I'll put the circuit diagram which I designed online, so that if you have this trouble and you fancy, you can build exactly the same thing. Here we are, 2 days later, and I have the circuit on a piece of strip board. There it is, and it's plugged into the pump, and when the tap is turned on, this will operate the pump. So what I'm going to go and do is turn the tap on and put the camera where you can hopefully watch it come on. There's a little LED which will come on, and you'll obviously hear the pump. Right, I should go and turn the tap on. Right, I'm going to switch on the stop clock here now, and you should see the light come on, and you should hear the pump operate. Oh, that's interesting. And there we go. And you can see the green LED there. And when the pressure comes up to, I think it's 0.95 of a bar, there you go, it goes off. Now the pressure is actually dropping, and it settles down to somewhere around 0.7, but it's got to drop below that before it goes on again. So the circuit has got some hysteresis in it, and that should be adequate. And if I've designed this right, it should outlast me. I wanted to show you also what happens to the water pressure and how the circuit responds. So I've connected up the voltmeter, and here you can see 0.718 of volt. That seems to correspond to bar. So the water pressure, I think, is about 0.7 bar. That would be around right, because the tank would be about 7 meters up off the ground. and that would be the water pressure that we'd register at the moment. Now if it goes below that, the pump will come on, the circuit will operate. And what's interesting about this is there's some hysteresis in the circuit, which means that the pump will stay on until the voltage goes considerably higher. In this case I've set it to go to up to 2.95 of a volt, and then the pump will switch off. The pump will remain off until the pressure drops back down below 0.7 of a volt. So hopefully what that means is the pump isn't cycled on and off repeatedly. I'll now go and see if I can get my friendly assistant, my lovely assistant, to switch on the pump for us. Please turn on the tap, oh beautiful assistant. Yes, hold on. Alright, now, oh beautiful assistant, please switch off the tap. And the tap is off. And we see that the pressure now continues to rise. Thank you. And at 0.95 it should switch off. There we go, just about. So there you have it. That's a little side project which I was forced to do. The next stage is to put it in a box and screw it somewhere on the inside there, out of the way, and call it a job done. Greetings. Day 15 or something of the pump saga. The pressure switch is now finished, it's working. So here it is. There we go, isn't that beautiful? Let me shine some light in there. Oh, and it's come on, which is good news. Yeah, it doesn't come on for long because it's already up to pressure, and that's someone turning the tap on, I think. Unusual that it comes on that often. But there we go, there it is. You see there's a little bracket around the transformer which I made up so I could screw it to the case. And that's it really. I think I might need to adjust the voltage bias on one of those potentiometers just a fraction, stop it coming on and off quite so much. And but that's it, that's the job. I'm going to screw the face on that, the panel on that, and then that's it, finished.